I'm Vaidehi. I'm so excited because today I get to introduce you to tree traversal. When you're dealing with data structures, especially in the realm of computer science, usually you want to do things with them. You might want to read the data from them, or update some data, or delete some data. But one of the most common things you want to do is traverse through the data structure. For example, when you're dealing with graph data structures, you usually want to traverse through the nodes of a graph. In a similar way, you might want to traverse through a tree data structure as well. Trees are actually just a restricted form of a graph, and tree traversal is just really a type of graph traversal. Another term for tree traversal is also called tree search. Usually, it involves checking or reading the data inside of every single node of the tree only once. Another term for checking or updating each node exactly once in the context of traversal is also called visiting. So you might hear the term, we visit a node, which just means that we're checking or reading or updating a node in a tree data structure. But checking or reading or visiting the node of a tree isn't really the tricky part. The tricky part is deciding the order in which we're going to do that with every single node in the tree. And the order in which we update and visit nodes in a tree while traversing is how we decide what type of traversal we're actually implementing. The order of traversal is how we classify tree traversal algorithms. So what do we mean when we say the order is how we classify an algorithm? Well, what we're talking about is the order that we're visiting nodes. And when it comes to a tree data structure, there's really only two obvious approaches to take. We can go wide and search through the tree, or we can go deep while we traverse through the tree. So let's start with wide. What does it mean to traverse wide through the tree? The term that we use for traversing wide through the tree is actually called breadth first search, which is also sometimes called BFS. In breadth first search, we traverse through the children of a node before visiting its grandchildren. In other words, we start at this root node, and then we visit its children before we ever move on to visiting any of its grandchildren. In other words, if we start to look at what's happening as we traverse through this tree, we'll see that we're actually traversing one level at a time. Breadth first search involves traversing through the tree data structure level by level. But breadth first search isn't the only strategy. There's another approach as well. We can also go deep into the tree as we traverse. This is something called depth first search, or the DFS strategy. In DFS, we traverse through the grandchildren and even the great-grandchildren nodes of a path before we move on to visiting a sibling node. In other words, we start at the root node, but then we pick a path and we continue down that path and continue visiting all the nodes we encounter until we get to a leaf node, one of the last nodes in the path. So for example, let's say that we chose this path. We would check the child node, check its child node if it had any, and continue doing that until we got down to the last leaf node on that path. In depth first search, we would traverse down one whole path of the tree before working over to traverse and check the sibling node. Note that we're not traversing level by level, but rather working our way down one arm or one branch of the tree before working our way back up to find and check another whole set of nodes in a path. These two strategies are the two ways of traversing through a tree data structure. We can go wide and use breadth first search and traverse level by level, or we can go deep and use depth first search, or DFS, and traverse down one path of the tree until we hit a leaf and work our way back up and continue that process. To learn more about these two strategies and tree traversal in general, head over to Dev2, sign up for an account, and follow me at Vaidehi Joshi. You can also stay up to date on all my future episodes. Thanks for watching.
Thanks to Heroku for sponsoring BaseCS. I'm Ben, one of the founders of Dev, and I want to give a shout out to Heroku, the platform that's allowed us to scale from 0 to millions of monthly visitors since we started this venture a few years ago. We rely on Heroku's managed Postgres alongside the rest of their infrastructure to ensure reliability and flexibility as we scale. If you're looking to scale a complex web app without all the chaos, please check out Heroku. Thanks a lot.